Welcome back, and we are now going to look at the structured questions. But before we look at the structured questions, I've received two questions here that I will have to try and attend to. The first question says, if you take down or downward motion as positive, do you have to take acceleration as negative or positive? With that question, I wouldn't like really to say downward motion as positive. Let's not take the motion of the object as positive, but let's choose the direction, say our direction downwards. Is positive. Then what do we mean? We mean that, for example, if we had the Cartesian plane where values above 0 are positive and values below 0 are negative, and values to the right of 0 are positive and values to the left of 0 are negative, then we would easily take upward as positive. In which case then we would say any quantity, vector quantity, that is pointed in the direction that we took as positive will have a positive value. But if then we take downward as positive, it's like we are reversing this Cartesian plane, where we are saying now the values below 0 will be positive and the values below above 0 will be negative, and hence in the same way. So if you first choose that my direction is downward is positive, then if an object is projected vertically upwards and you take downward as positive, note that your initial velocity will be, because the object is pointed, is projected upwards, your initial velocity will become, you said downward is positive. So your velocity is directed upwards, which is the opposite of what you took as positive. So your initial velocity will be negative, but your acceleration g, due to gravity, which is 9.8 meters per second squared, your acceleration, because the object, even though it is moving upwards, the acceleration due to gravity is always pointed downwards. Now, depending on the direction that you have chosen, downward is positive, so your acceleration will be directed downwards, so your acceleration will take a positive value. So your acceleration does not necessarily change, become negative and positive. It will depend on the direction that you as a learner have chosen as before you start solving the problem. So if you choose downward as positive, then your acceleration due to gravity will be in the direction that you chose to be positive, therefore it will be positive. But notice that if we had taken our direction upwards as positive, then the acceleration due to gravity will be acting in the direction opposite to that, therefore it will be negative. Usually if you look at a projectile, an object that is projected upward, depending on the direction that you choose, you'll find when, let's say we are saying downwards is positive, the initial velocity will be negative, while the acceleration due to gravity will be positive. But if you choose upward as positive, the initial velocity will be positive and the acceleration due to gravity will be negative. And this is what most learners have a problem with. You'll find that even if an object is a projectile, they keep the same direction for both acceleration and initial velocity, which in fact should be opposite, because the acceleration due to gravity will be in the opposite direction to the initial velocity. So those will have different signs. I hope I have attempted to answer that question. The second one says, if the object is projected upwards with the direction being chosen as positive. So we take upward as positive. Then she says the object returns to the starting point, to the ground. So it goes up, it comes back, it passes that starting point, and then it overshoots and comes, say, to the ground here. Now, we have chosen our direction up as positive. That is what she is, or he is saying. Will the gravitational acceleration be negative or positive when calculating the final velocity? Now here I think it goes back, it's the same question really. It goes up and then it comes down. Notice that your acceleration is always directed downwards. So if you chose up as positive, then your acceleration will always be pointed downwards. So if this is positive, upward is positive, your acceleration will be negative 9.8 meters per second squared, irrespective of whether the object is moving up or is moving down, because the original direction that you chose is up, is positive. So your acceleration due to gravity will be downwards. This is similar to one of the multiple choice questions that we talked about, that when you project an object upward, what will be the direction of its acceleration? It is always directed downwards. I hope that also explains the second question, which I think is more or less the same as the previous question. Now, let's see if we can be able to look at this question. Notice the highlighting of words or even statements that I think will help me to deal with the question. It says, a boy stands at the edge of a high cliff. He throws a stone vertically upwards. So he stands at the edge of a high cliff. That tells us that this person is standing at a point above the ground, because it's a high cliff. He throws a stone vertically upwards with an initial velocity of 10 meters per second. So the initial velocity is 10 meters per second. It's directed upwards. So that's the, we call it the trajectory, the path that the object is going to take. It will first go up, reach its maximum height, then go back to its original position, then past that original position. And then it actually answers the question that you asked. So if we were to take our direction up as positive, then it means that the acceleration, because it's downwards, will be negative. The stone strikes the ground at a point below the cliff after 3.5 seconds. So the time that is taken for the complete journey, or for the complete motion of the object, is 3.5 seconds. Then they say the velocity time graph below was obtained from measurements made during the motion of the stone. So after measurements were made, whoever was studying this motion of the object came up with this graph probably in the same way that we did, where we plotted the velocity of the object against time, and we had those coordinates and plotted the graph. And you will see how this graph resembles the one that we used as an example. Now, they say we should use the information from the graph to answer the following questions. 1.1 says, calculate the acceleration of the stone between the time t 2 seconds and the time 3 seconds. They say acceleration. Now we know, now we are looking at time 2 seconds and time 3 seconds. What do we have in our graph here? Perhaps before we can actually look at the questions, maybe we need to interrogate the graph just to find out what other information can we get from this graph. They are saying the object is thrown vertically upwards. In other words, the initial velocity of this object is 10 meters per second. We can also say that, according to this graph, the upward direction was taken as positive because the initial velocity is positive. It lies above the x-axis. It's above 0, so it is positive. After 0.5 seconds, because we have 1 second there, after 0.5 seconds, the velocity of the object was 5 meters per second, which shows that as the object goes up, the velocity decreases. In other words, it is accelerating, it experiences negative acceleration. After 1 second, the velocity of the object is 0. I think the relevance of these graphs becomes important. After a certain time period, the velocity is 0. And from what we learned earlier, when the velocity is 0, that is when the object has reached its maximum height. So at this point, we can safely say that the object had reached its maximum height, and it reaches its maximum height after 1 second. Then what happens? The object changes direction. Now it moves downwards. The negative values here indicate that the direction of motion of the object has changed. So the velocity, although it is increasing, notice that when the object now moves downwards, it is actually, its speed from 0 is increasing. So because now we are talking velocity here, the velocity being a vector quantity will be negative. So it goes back to say after 1.5 seconds, the velocity is now negative 5 meters per second. But this object is still accelerating, but it is accelerating downwards. The velocity is negative. After 2 seconds, what do we realize? The velocity of the object is now 10 meters per second, but in the opposite direction to its original direction of projection. That velocity is equal to the velocity with which the object was released. What does that mean? It means at this point the object returns to its original point of throw, where the initial velocity will be equal to the final velocity when the object comes back. So if I were to use this diagram, then I would say the initial velocity was 10 meters per second upwards. When this object comes back here to the point of throw, its velocity will now be minus 10 meters per second. I think that makes sense. Now it shows the relevance of the graphs that we drew earlier on. After 3.5 seconds, the object has already overshot its position of throw. It hits the ground at about that velocity. So that is 3.5 seconds. Now can we try? So with this already you get a picture of the motion of the object with respect to its velocity, and it explains the different parts of its position as you look at that. Let us also notice that the graph is a straight line graph. Being a straight line graph, it tells us that the slope of that graph is a constant, and that slope gives us the acceleration of the object. Since the slope slants to the left, we expect this slope to be negative. And if we go back to what we said earlier, if the direction of motion was positive, not direction of motion, let me say our initial choice of direction was up is positive, then we would say that the acceleration due to gravity, because it's directed downward, it will be opposite to the original direction that we have chosen as positive. So our acceleration due to gravity must be negative. I am trying to emphasize on the questions that you actually asked on this. Okay, 1.1 says calculate the acceleration of the stone between t2 seconds and t3 seconds. There are possible a number of ways that we could do this, but perhaps the easy one out would be for us to look at the gradient of that. So we would say that the gradient or the slope of that graph will be given by change in velocity, which is the acceleration, change in velocity over change in time. But we should notice here that the question requires us to find the gradient between time t2 seconds, which is at this point, and also at that point. So we must look at the coordinates of this. What was the velocity there, and then what was the velocity there. So with respect to, if we were to call this t1 and then t2, then this will be the corresponding velocity to v1, and this will be the to t1, and this would be the corresponding velocity to t2. So this is the section of the graph that we'll be looking at. In mathematics, you know that you just look at the, you make a triangle there where you actually calculate the slope. So that will give us the change in velocity will be given by that would be v2 minus v1, which would be minus 20 minus our initial velocity will be minus 10. What will be our change in time? Is t2, which is 3 seconds, minus 2, and this will give us, of course that becomes now positive, so we have minus 20 plus 10, which gives us minus 10 over 1, and that gives us an acceleration of minus 10 meters per second squared. That is the the gradient. And we notice that this gradient is negative. As a matter of rule, we have to interpret that to say the gradient is, or the slope is, or if we were to talk about the acceleration, then we would say that this acceleration is 10 meters per second squared downwards. So we can therefore say that the acceleration or the gradient or acceleration is equal to 10 meters per second squared. And this is directed downwards. I think this now answers our questions. The slope is negative. If the slope is negative, the acceleration will be negative. My dear learner, you asked why do we use 10 meters per second squared. Of course, like I indicated, the actual acceleration due to gravity is 9.8 meters per second squared. But for making calculations like this one's easy, then you can see that the examiner here set this in such a way that your gradient becomes 10 meters per second or minus 10 meters per second squared, so that it becomes easier for you to deal with that. The other way you could do this problem would be, because the question says use the information from the graph. Now the information that you have from the graph, that we can elicit from the graph, what is the information that we can elicit from the graph? I guess between these time intervals you have the initial velocity. So you could say we are looking at the acceleration. Therefore, you could alternatively say V final is equal to V initial plus A delta t. I think we could be able to do that, because if we look at the initial velocity, now we have to make a choice of direction. We can say up is positive. Then we can say we are looking for acceleration. At least we have the initial velocity, which is in this case 10 meters per second. But notice that this 10 is upwards, so it will be 10 plus, we are looking for the acceleration. Our change in time will be between 2 and 3 seconds. So our initial time there is 2 seconds. The final time is 3, so we have 3 minus 2. And where will be our final velocity? We started here, we get to the final time there. I think we will have minus 20. That will be our final velocity. Notice that after 3 seconds the object is moving down. So we are using the initial velocity we are using. Oh no, by the way, we are not going to use this one because we are looking at the between t2 and that, so our initial velocity will be this one, which is minus 10. And we said this is up is positive, so this is minus 10. So we are going to say at 2 seconds, because we are looking at the time interval 3 and 2, so we look at the corresponding velocities there between t1 and t2. So we are going to say that we take this one, this side, it becomes negative 10 is equal to a multiplied by 1. So you can see that our acceleration is actually negative 10 meters per second squared. So by using the equations of motion but taking the information from the graph, we can be able to get the correct answer as we did there. 1.2 says, at which times is the stone moving at a speed of 5 meters per second? Let's check that. They say the speed. They are not saying velocity. So the speed here does not, it's a scalar quantity, so we don't really look at the direction, but we look at the magnitude of the velocity. Sorry, of the speed, the magnitude, just the number, how big it is. And here they're saying the time. Notice that here you are given a possibility that it may not be only one time. You are not only going to look for one point. There can be a possibility of having several different possibilities there or answers. So they are saying, at which time or times is the stone moving at a speed of 5 meters per second? Now we look at here the first one, the speed of 5 meters per second is there, and we realize that it corresponds to the time of 0.5 seconds. So our 1.2 will be, our times will be 0.5 seconds. Is there another possibility? You also see that here we have 5, but if we are looking at speed, the velocity will be there. Where does that line touch, or where that line touch the graph? At 1.5. So the other time that is possible will be 1.5 seconds. Yes. (1.3) says, after how many seconds does the stone reach its highest point? When we interrogated the graph here, you will have noticed that we said it starts with a velocity of that 10 meters per second upwards. The velocity becomes 0 at the point where the object reaches its maximum height. Therefore, the velocity is 0 when the time is 1 second. So for 1.3, this is just going to be 1 second. That is the time when the object reaches its highest point. And you can also see that you're just given a mark for that because you are not doing any calculations. You just have to get the information from the graph. 1.4 says, determine the height of the cliff from which the stone was thrown. Now if we go back to that diagram of ours, we were told that the object is thrown from this cliff. Now we are looking at the height, delta y, here. That is what we are looking for. And I think we know we are given the time. Maybe we can indicate what information we have. We are given the time for the motion is 3.5 or 3.5 seconds. We know the initial velocity is 10 meters per second. We know we are looking for the height. Do we know the final velocity? We don't. Okay, we know the acceleration due to gravity, which is 9.8 meters per second squared. I want you to ask questions while I do that. Now, what we are supposed to calculate delta y. One important thing that we need to note is that whenever we use these equations of motion, we will actually be having these quantities: time, initial velocity, final velocity, acceleration due to gravity, and the change in position. So if you have any three of these quantities, you know that you can use any one of the equations of motion to be able to get your whatever quantity you are looking for. Now let's go back again and say our choice of direction will be up. Notice that I'm trying to be consistent with this up as positive. I will also indicate to you that you can choose your direction down as positive. It will still be fine, and then we'll see how we do that. Now I think in this case we are looking for delta y. We are not looking for the time. So we would say that delta y is equal to v initial delta t plus half a delta t squared. We have chosen our direction up as positive. Then we can look at the quantities that we have here. In what direction was the initial velocity? The object was projected upwards with an initial velocity of 10 meters per second. So you can make this positive, safely do that. But in what direction is our acceleration pointed? It's pointed downwards. That tells us that our acceleration will be negative. So you can do that here on the quantities that you are given, or alternatively you would do that as you substitute here. But I think it would be easier if you choose the direction and then you just based on your choice of direction you work that out there. So we substitute in there. Our initial velocity will be 10 multiplied by the time, which is 3.5, plus half of the acceleration, which we said is minus 9.8, and then we multiply that by 3.5 squared. Now I must get my calculator, which seems to have escaped me. I think you can work that out. This of course will be 35, plus this will be minus 4.9 multiplied by 3.5 squared. So let's see that 4.9 multiplied by 3.5 squared gives us that. And then maybe we can just subtract 35 from that. What have I done here? Okay, 335 minus 4.9 times 3.5 squared. That gives us 25. Go 2 meters. Just trying to check and confirm here. Okay, we will look at this. Perhaps I've made a mistake somewhere. But we can also look at another possibility. We'll check this again. We can look at another possibility. The height of that cliff can also be obtained. I'll check where, you can check with me where the mistake is. We can also look at the height, because that will represent the distance. The height of the cliff will be found by taking the distance or the area of the graph between these 2 points. The height of the cliff from which the stone was. No, not just between this point, because this is the point where it was thrown. So we will look at, oh gosh. Oh yeah, I see where my mistake is. Let's check. We'll get back to that. Remember that our acceleration is not 9.8. Remember from the graph we calculated that in the first one. So our acceleration is actually minus 10 meters per second squared. I think that's where I made a mistake. So if you substitute that 10 here, then we are going to have minus 10 there. And then we have 3.9. So this is going to be minus 5. We multiply those, so that is 35 multiplied by that. So we get 35 minus 5 times 3.5 squared. And that will give us, yes, it is actually 26 minus 26 comma 25 meters. Yeah, that should be. So this is how we would do it. Excuse me for the carelessness there, but I forgot that our acceleration due to gravity in this particular question is not 9.8, but it is 10 as calculated earlier. So we could work that out and find this answer. Now 1.5 says, using the top of the cliff as the initial position of the stone, sketch the position time graph or the displacement time graph for the motion of the stone from its highest point until it reaches the ground. We are using the top of the cliff, remember our diagram, as our ground. They say, let's use that as the initial position, so it is thrown from that point. So when we draw our graph, we will look at Perhaps maybe we can also extend this downwards a little bit. Sketch the position time graph for the motion of the object from its highest point until it reaches the ground. So we will look at the time intervals that we have here. The time intervals that we have are, we have 1, 2, 3, up to 3.5. So we will have 1, 2, 3, etc. But notice now here they said we should sketch. So we really do not need to have all this. We really do not have to have all this. So what we will need to do is just to check what was the original position of the object when it was, what was its position at the top of the cliff when we threw it up. Its position was at 0. And then after how long will it reach the highest point? Then we notice from this it reaches the highest point after 1 second. So the highest point will be reached after 1 second. Then when does it come back to, it reached the highest point after 1 second. It comes back to its original position after 2 seconds. So after 2 seconds it will be there, and then it overshoots that, and then in about 3.5 seconds it will have reached the lowest point. Now our lowest point will be somewhere there. I think my graph is not so nice. But now, if we look at the question says we should sketch the position time graph from the highest point, when this was at the highest point, until it reaches the ground. So we look at, we are not going to take this part here, because here that was when the object was at the original point of throw. We will look at the point where it was at its highest point. That will be after 1 second, and our graph will go something like that. Now what we notice here is at the highest point, they are saying we should draw the position time graph. So this is a position in meters, and this will be the time in seconds. Notice that this graph in essence does not have to be a straight line graph, because the object is accelerating at the same time. So we don't really have to worry so much about that. And the position, I think we at the highest position we could calculate that. So they say we only indicate relevant time values on the x-axis. So the relevant times, I think we have indicated our 2 there. We have indicated our, oh, I'm sorry, this should be 3.5 not. That's why it should go this way. So that graph will move like that. Where we have 3.5 there, so this is going to be 3.5. Basically this, and of course our graph must be labeled position time graph. And that is how we get that. Apparently, we have not done all the questions that I would have loved to do with you. But maybe I can just highlight a few things. It is important for us that we underline or highlight important words that we should do, important words that the question gives us, so that this will guide us as we answer questions. For example, if you look at this one, when it says from its highest point, it is important that we notice that the first part of that graph we leave out. The first part of that graph we leave out, because if we had included it, indicating the original graph that we had, then this part is not required. But you will see that the shape of the graph of a projectile would be obtained, where you have the object starting at a certain position, going to its maximum height, and then going back to the point of throw, then it overshoots that and it goes down. But the question says we do not want this first part here. We only want the part where the object is at its highest point and as it moves back downwards. So we want to emphasize that you highlight those important points. You write down the information that you are given, and also make sure that you have a choice of direction. The choice of direction will be made by you. You have to tell us, do I take downwards as positive, or do I take upwards as positive? If I may have to go back to that question 1.4 again, I would therefore say that if you had your choice, because here we took up as positive, if your choice was down as positive, then what would you have done here? You would have looked at the initial velocity of the object. So your initial velocity would be upwards, so it would be negative 10 meters per second. And your acceleration, remember that acceleration goes downwards, therefore your acceleration due to gravity, remember we said our acceleration is not 9.8 but 10. Our acceleration will be going downwards, therefore it will be positive 10 meters per second squared. So you see the difference here when you substitute. Then your initial velocity, if you chose the direction downwards as positive, your initial velocity would be negative, and your acceleration would be positive, and you'd still be able to get the answer there. And finally, perhaps it is important that when we get to our final answer, we interpret this because it is negative, then we will therefore say that our change in position or the height of the cliff is actually equal to 26.5 meters or 25 meters. So we also have to interpret the answer as we get it there. That will bring to an end or to conclusion this part of presentation. I think my colleagues will also come to do the next round on the same vertical projectile. I thought I would be able to cover much more than this, but unfortunately within the time that I've worked in, I could not cover that much. But I hope with a few tips that I have given you, you will definitely be able to grasp something, except for my bad handwriting there. I hope things will improve in the future. But thank you very much for being such a wonderful audience. Yes, just before, I had already concluded, but I learned that there is a question by Elena, which says, should we indicate the choice of direction only at the beginning of the question? Let's say it's question 1, and then for everything that we do for that question, we use that choice of direction. That, I think, we would encourage, because it will help you to be consistent throughout your answering of the question. However, if you decide maybe to change the direction, the choice of direction, based on the information and the ease with which you think you'll be able to do the problem, then it is important to indicate that for this part that I am dealing with, my choice of direction, say if in the initial one you had said it was up, indicate in that one that my choice for this one is down, will be positive. So in that way, it removes the confusion. But we would recommend that if you choose that direction, you work with your choice of direction throughout the whole problem. But in most cases, you'll find that you need to change direction, because it will be easier for you to work with the question. Thank you.